welcome to Starship TV. Teleportation, scientific research, speculative projects, and societal impact. 1. Introduction. Teleportation, the instantaneous transfer of matter or information from one point to another without traversing the physical space between, has long been a staple of science fiction. However, in recent decades, scientific research, especially in the field of quantum physics, has begun to explore real-world applications of teleportation on a very limited scale. This report examines current research, speculative secret projects, and the transformative potential of teleportation on human society. 2. Scientific foundations of teleportation. Quantum teleportation. Quantum teleportation refers to the transfer of quantum information, qubits, between particles over a distance using quantum entanglement. This process does not involve the physical movement of the particles themselves. Key milestones. 1997. Researchers at the University of Innsbruck in Austria successfully teleported the quantum state of a photon for the first time. 2015 to 2020, quantum teleportation distances increased significantly, with experiments over 100 kilometers using fiber optics or open air. 2020, scientists at Fermilab and Caltech reported sustained, high-fidelity quantum teleportation over 44 kilometers of fiber. How it works. Entanglement: two particles are linked such that their states remain correlated. Bell measurement: a measurement is made on one of the entangled particles and the particle to be teleported. Classical channel: the result is sent to the destination, where the quantum state is reconstructed. Limitations: only information, not matter, is transferred. The no-cloning theorem ensures the original quantum state is destroyed. Teleportation of humans or large objects is not currently possible. 3. Speculative and classified projects. While there is no confirmed evidence of matter teleportation in any government or private sector programs, several theories and claims persist. Alleged military research. Project Pegasus, U.S. allegedly a DARPA project in the 1970s, discussed by Andrew Biago, who claimed teleportation and time travel technologies were tested. These claims remain unverified. Russian and Chinese interests. Open-source materials suggest both countries are investing in quantum communication research, which could be related to teleportation technologies. Fiction versus reality. Many reports of teleportation in classified programs are speculative. There is no peer-reviewed evidence suggesting successful human or object teleportation has occurred beyond the quantum scale. 4. Theoretical possibilities of matter teleportation. While current technology does not allow teleportation of physical objects, some theoretical paths have been considered. Molecular scanning and reconstruction. Disassembling an object atom by atom and reconstructing it at another location, requiring enormous computational power and energy. Wormholes, hypothetical tunnels in spacetime, allowed by general relativity, might permit instant travel, though none have been proven to exist or be usable. Teleportation via energy conversion involves converting matter to energy and back, as in Star Trek-like transporters. This faces enormous physical and ethical barriers. 5. Potential societal impacts of teleportation. Economic and industrial transformation. Logistics and transport: instantaneous delivery of goods could eliminate the need for shipping, trucking, and air freight. Labor markets: drastic shifts in job markets, pilots, drivers, couriers may become obsolete. Energy use: reduced fossil fuel use, but increased demands for quantum computing and teleportation infrastructure. Medical and human applications. Emergency medicine: patients or organs could be teleported instantly to hospitals. Remote surgery: combined with quantum communication, teleportation could enable near-instantaneous remote operations. Ethical and legal challenges. Identity and continuity: would a teleported person be the same individual or a perfect copy? Security risks: instant travel could facilitate unauthorized access, smuggling, or even warfare. Inequality: societal divide between those with access to teleportation and those without. Global implications. Geopolitical realignment: borders and distances become irrelevant, reshaping power dynamics. Urban planning: cities could be reimagined if commuting becomes obsolete. Environmental recovery: reduced emissions from transport might help mitigate climate change. 6. Conclusion. Teleportation, while mostly a theoretical and quantum-level phenomenon today, represents a field of immense curiosity and potential. Although current science restricts us to teleporting only quantum information, the rapid pace of technological advancement suggests that what is impossible today may one day become achievable. The societal, ethical, and practical implications of teleportation would be profound. Governments, researchers, and the public must engage with the philosophical and regulatory questions now, preparing for a future that could redefine the boundaries of distance, identity, and even reality itself. Quantum AI and teleportation. What is quantum AI? Quantum AI refers to artificial intelligence systems that operate using quantum computing principles, allowing them to process vast amounts of data in parallel thanks to qubits, superposition, and entanglement. How it could enhance teleportation. Real-time quantum state calculation. Quantum teleportation requires extremely fast and precise calculations of quantum states and entangled particles. Quantum AI could optimize and manage the entanglement, measurement, and reconstruction processes more efficiently than classical systems. Error correction. One of the major issues in quantum teleportation is decoherence. Loss of quantum information due to environmental noise. Quantum AI could learn to detect, predict, and correct quantum errors in real time, vastly increasing teleportation reliability. Entanglement network management. Managing a global or interstellar quantum teleportation network would require optimization of millions of entangled pairs. Quantum AI could coordinate these networks, sort entanglement bottlenecks, and ensure successful state transfers. 2. Zero-point energy, ZPE, and teleportation. What is zero-point energy? ZPE is the lowest possible energy that a quantum system possesses, even in a vacuum. It arises from quantum fluctuations and is thought to permeate all of space. Theoretical uses in teleportation. Energy source for matter disassembly/reassembly. If physical matter teleportation ever becomes feasible, e.g., via molecular scanning and reconstruction, it would require massive energy. ZPE has been speculated, though not confirmed, as a practically limitless energy source that could provide the energy needed to dematerialize and rematerialize matter. Vacuum manipulation for wormholes or space bending. Some speculative physics suggests that manipulating the vacuum energy could allow for wormhole stabilization, a hypothetical mechanism for teleportation through spacetime. ZPE might be necessary to keep a wormhole open long enough to transport information or matter. Casimir effect for quantum portals. The Casimir effect, a manifestation of ZPE, shows that vacuum fluctuations can produce force between objects. Some fringe theories suggest that engineering such effects could one day allow for temporary quantum bridges between locations. 3. Combined vision, quantum AI plus ZPE plus teleportation. Imagine a future teleportation system where ZPE provides a nearly limitless source of clean energy. Quantum AI calculates and manages the teleportation process, correcting quantum errors and routing entanglement nodes. The system teleports physical objects or humans by either transmitting quantum states with atomic scale fidelity or facilitating instant movement via artificial wormholes. This combination would essentially redefine physics, logistics, and consciousness. You're watching Starship TV. Be sure to like, comment, and subscribe. Thank you.